Okay, let's see if this is working. Hey, no. Yay, cool. Is this working? Yay, cool. Hey, is this working? Yay, cool. Hey, is this working? Yay, cool. Hey, is this working? Like, back to this. I have no idea if audio is working. I actually do have a new microphone that I'm testing today, so let's see how that goes. So, welcome back. Today I have to do some research into Llamafiles and running some things on local devices. So I'm going to be focusing more from today on local AI. And it's going to be very unstructured today, but since I had to go and look into some of these things, I thought I could do that while streaming, and you get to hear me getting confused. Uh, Hopefully it's useful in some way. So let me just see if everything is working on my side. Hopefully anyone can hear this. Okay. So before I start, yeah, I've been doing more for YouTube now. So I've released a video recently on how to run local AI using LM Studio. But now I want to go a bit further and start looking to Llamafiles, Whisper, CPP, low power devices, and maybe even kind of doing some of my own C code at some point. Okay, cool. So today, what I had in mind, I don't really have a goal other than just exploring. So again, it's going to be very, very unstructured. I was thinking about looking into getting some Whisper running. I'm not sure how that's going to play with having streaming and recording the audio for Whisper. But yeah, so I'd like to get some Whisper running so I can transcribe what I'm saying and then forward that to some LLM. Not sure if I will get that far. I will have about 30 minutes to maybe 45, tops an hour. We'll see how it goes. So let's see. So one thing I wanted to start with is I found this website, Justine's webpage. I mean, this is very incredible. I'm not sure if, I mean, maybe she's very popular already in the community. I'm sure she is, but I did not know about this until today when I saw a link into Cosmopolitan libc, and this is pretty cool. Pretty cool. Um, so if I'm not mistaken, I don't know if this is the base for Llamafiles, but it's at least used in some place there, and she's done some very good contributions there. And it's a library that helps turning C codes. Well, it just makes C code way more portable. So the idea is that you can run C code anywhere. My prediction is that C is going to gain popularity again. So it has been very, very popular in the past, but like C and C++ will probably start growing in popularity soon again. And my prediction is that cost and performance is going to be back into being one of the core features. So what is Llama? Llamafiles. Llamafiles. So this is a Mozilla project, and it's pretty awesome, actually. I'm recording a video soon on this for YouTube. Let's see how that goes, but this is pretty awesome. It's basically a executable. So this is a file you can actually run, and it has both the model, all the parameters, all the weights, and also it's packaged with something else sometimes as well. So you can include a web server, a very simple one, and you can then interface with the model using the web server. But for example, there's already Llava package. There's a Llama file with image input as well. There's Llama, there's a few other models, and then I've seen a project of someone trying to get Whisper CPP into a Llama file as well. But one thing I have no idea yet how to do is that so I've tried the other day to run Llamafiles, pretty easy, and I'll do that today again. But I don't yet know how I would go about interfacing with those models that are running from like a different Python script or somewhere else. Because what I want to do is to pipe Whisper outputs into Llama. So let's see. Okay, for now, let's forget this. So where was I? Whisper.cpp. So this is kind of the standard one. Also very easy to run, so we could do that. It has a stream mode, which is pretty cool. And ideally, we would get this working without even touching Python. Yeah, this is something I'm looking into for tomorrow. For now, let me put it out of here. Okay. Let's see. Yes. So we're doing that by combining Llama CVP with Cosmopolitan libc. So it is indeed built on top of it. Like this is, I mean, I cannot stress enough. This is very cool. I mean, I'm a good type of jealous of these people, to be honest. If there's a good type of jealous, whatever the word is. Okay. So let's see. Lava model. So this is what we're going to do. Lava. I mean, so many things happening, so many cool things going on. It's kind of hard sometimes to know where to look. So that's why I'm thinking of using some of the streams as more of like unstructured time of just exploring things. And hopefully, I mean, if anyone's watching now or in the future, also leave some comments, maybe ask questions or suggest things to look into. My current plan is to use YouTube as more of the structured approach in projects, and Twitch will be where I do some level of like research, exploration, etc. Okay, so what I've been doing is just because I now like running models wherever I am, I'm creating a little model store. Just a folder with a bunch of models, and I'm definitely preferring llama files. There's also a way to convert other formats into llamafiles, so I might try and do that. One thing, if anyone knows, so if you're watching this the replay on YouTube, also please comment. I would really like to know if there's any kind of a local model store management, something like Hugging Face, but for the local machine, like a in between Hugging Face and Git. I guess there's LM Studio, but something more like in the command line. Yeah. Okay. So let's do this. So let me show you how easy this is. So literally, you do something like this, convert all the llama files into executables, and then let's see Llava. Boom, it's running. So now, give it a moment. Bam, there you go. So UI is a bit simple, but it's very good, I would say. So first thing that comes to my mind is like, and of things to continue researching, I'll start taking notes. You won't be able to see them, but is I want to know how I can package my own UI into a llama file. So how to package my own UI into llama files. So that's probably coming in a stream soon, not today. So this is a pretty standard LLM. We can chat, we can give it a prompt, username, bot name, prompt templates, etc. So this is cool. chat history templates, grammar. This is actually very, very cool. So you can basically, you can control the outputs by providing a grammar. So we could have the JSON spec or schema here, and then the output will always be valid JSON. I'm actually not sure if it would always be, or because I'm not entirely sure how this works, other than somehow it can control the output. So that's something to research. Okay, predictions, temperature, all the settings. So more options. Wow. Some of these things I don't fully know what they are. We will look into that soon. API key. Is this just, okay, well, I guess it's so that I can run this elsewhere, right? Yeah. Okay. Actually, a cool thing. I work at a place called Glyphic AI, which we extract knowledge from calls for sales pipelines and just sales calls and to help salespeople. One thing I'm now thinking is like it would actually be very cool if I could do the same for these videos and extract just the highlights or the main notes of the video, almost like go from exploration to tutorial automatically. That would be cool. Okay, so let's just see if this works. We want to upload an image. What are we going to do? We're going to take a screenshot. Let's see if it knows about itself. Okay, we'll save that. Where is this screenshot? You probably cannot see that. Okay, where is this screenshot showing? And no, this is not what I want. What do I want? Oh, yes, upload image. Not that. Okay. Okay. Did it finish? Not sure what happened there. Just gonna try one more time. Okay, I'm going to assume that yes, it's there. Okay. Is this working? It is working. Look, that's pretty good. Yeah. Actually, what's the size of this model? It's the 7 billion. Okay. So displays a screen with multiple fields. Yeah. So I guess it doesn't know about itself, but that's expected. This suggests the user could potentially edit or manipulate sound files using these tools. So that's interesting. Where is the audio waveform? Okay. Well, actually, let's ask. Feel like the reset is where the send should be. Okay. Yeah, I guess the image goes into the history. So we're going to be processing the image all the time. Of the image next to the purple line. Is it? Yeah. Oh well. Okay. Some level of hallucination. Okay, so that was easy enough. That's how simple it is. Now the other thing is I managed to get the whisper tiny working as well. The downside on this one I found is that it only supports sending audio files, and what I want to do is more like real-time talking to it. Okay, for now let's stop. But at least it's a good way to locally just transcribe some files. Okay, so let's see. So we've done all these. So when it is started, okay, so we get the UI in there, but it is also OpenAI API compatible. So that's pretty cool. So that means we could build our own UI as well. Although I quite like the idea, let's stop this one. I quite like the idea of having a llama file that is, I don't know if it is possible or not, but if I can package my own program with my own web page, basically just having everything packaged in one, and you run it and you get a full application with UI, etc. There's no external application running. That would be cool. At least for me, that I have some ideas that would require that. Okay, let's run this. Okay, so this is a previous project. Let's stop that. We're going to need this. Okay. So what are we going to do? We're going to explore Llama. It's like a recursive thing. So we have a folder called research llamafiles with a folder called explore llamafiles. Great. You know what? Give me a second. It's rubbish. We want to create a project. I need to create a template for Python. Okay, so do we? I think I'm being silly right now. This is what we want. So now I'm using Z, which is a pretty fast editor. Resembles of VS Code, but it's, in my opinion, much better, although it's early days. It's very fast. That's the other thing. Okay, so main. So if there you go. Great. Okay, so what we're going to try and do, we're going to create a virtual environment. Okay, activate. There you go. Should we operate? Why not? Okay, so now import OpenAI client, OpenAI client. Now here is, if I remember properly, we want something like this. What support? 8080, okay. No API key, that's fine. What model do we need? Do we need to provide a model? That's interesting. Okay. Ah, this is interesting. Okay, let's do it. Let's do a headless version of it. So we can basically do Llava, no browser, boom. Okay, so we got that. We should be server listening on 8080. All slots are idle and system is empty. Clear give you cache. Okay. Play slots. Give you buffer. Okay. There you go, model name. Oh no, but that's not what I want. Okay, let's just try run. I do not remember on top of my head all the arguments here, so we'll need messages, I guess. Yeah, there you go. Roll. You are a funny assistant. Okay, yeah, that's fine. Okay. What? Okay, for now, let's go with this. Okay, API key. Let's do it. API key. We don't care. Empty. Can we do that? Okay, now it's a point where I need documentation. Okay, OpenAI docs. I should probably have some templates for these kinds of things. Where's happening? Okay, we don't care. Making requests. That's what we want. Okay, so we've got that. Chat completions. Let's put it here. Let's move a little bit. Client. Chat completions. Create. Okay, let's see what we get. Hmm? How do I set the environment in Z? We do not know. Okay, hey Z. Okay, I'll figure that out later. Okay, so we've got that. It is so slow. What is going on? Windows server. Oh, great. Actually, I've noticed that every time I open any OpenAI website, it seems to just drag. Something goes on. Yeah, it's gone. It's like, what is this? Whatever. Okay. So quick start, Python there. Ah, yes. OpenAI. Is this it? Missing required arguments. Okay, yeah. So model. So we can do this and then model. I mean, maybe it's this. I'm not sure if I even need to provide anything. Ha, is it working? Where is this? No. I mean, went further. Okay, continue. Oh, what is going on here? Okay. Okay, let's continue looking into documentation. Um, Actually, this is what we're going to do. Let's start with this. Oh, no. Well done. Okay. Okay, model llama CPP. That may well be what we were missing, but I don't think that's the whole story. We got something. Slot is processing a task. Boom. Okay. So let's see. Oh. Okay. Um, okay, so they've got, yes. Now, this is where reading documentation helps. we think. So next one is reading actual outputs. So actually, let's run just one more time. So connection error. Let's see. Um, sorry. Sorry. Illegal header value pair. Oh, okay. So this is indeed something we need to. We probably need to put something. Okay. Lesson learned. Read documentation and errors. Okay, we're processing. We cool. So message. So then we go choices 0 message content. Okay, we should also be able to upload images. I've done something like that before when we were doing LM Studio, so I'm going to skip ahead a little bit. Oh, there you go. So I suspect this is the stop token. I wonder if these things can run tools. Okay. So we can run. We have something that runs. What am I doing? Okay. Okay. What is this? Let's trust them. Okay. Okay, so we've got some. I'm really getting quite annoyed that I don't know how to set the virtual environment here. For now, I'm not going to be doing this. Okay. So we got a way to distribute models as a single file. Uses llama.cpp and cosmopolitan libc, which is this library to make C portable. This is something I want to explore very soon, maybe another day. And I need to figure out how to show that it is portable. We got some model running. We've done all this, we've done all this. Other examples, we're going to skip ahead for now. Okay, what other options? Okay, we can run it straight away from the command line. So how does it work? So it is an executable, and it contains basically the entire thing we need, including all the dependencies. And I quite like this, but I can't stop thinking that it would be cool to have like a somewhere, like the models are pretty large. Having, like, for example, having each application package their own model would not make sense. I also don't think that's what they're going for. But it would be cool to have like a way to switch between different models on a machine. Just make sure that a bunch of users have the same models, similar to what Apple is doing, but just across the board in open source. And then applications being able to link into a specific model. So it's kind of kind of diverging there, but I'm thinking something similar to Hugging Face, what they already do for Python, and it's pretty cool. The downloads the models that it needs. It's easy to set up, but more at the application level and not necessarily just Python. It's a bit like a bunch of llama files that get downloaded and they're used as dependencies for other applications. Okay, this is let's zoom. Okay, so llama files can run on multiple CPUs architectures. I read, I think, somewhere that also uses the GPU, so it's ready for that. You need to build your code once using the, okay. The weights of the LLM can be embedded within the llama file. Cool. So, okay. Tool included in this project to create your own llama files using any compatible model weights you want. You can then distribute. Okay, so using llama file with external weights. Ah, that's interesting. Even though our example llama files have the weights built in, you don't have to. So I guess you could keep the entire executable and then just load different weights, and this might be useful, I suspect, if you're fine-tuning or expect to and want to swap. External weights. Ah, yeah, Windows users, because they enable you to work around with. Oh, okay. But I suspect it's also pretty useful to have something that you can just swap the weights and update every so often. Although the rest of the code is probably small enough, if you just always update the entire llama file, it's easier to set up. Okay, but that's interesting. So in macOS, you need Xcode. Yeah, that's fine. Okay. On some, okay. Okay. Supported OSs, supported CPUs, GPU support, so this is good. Okay, so you can disable that. Maximum offloading. Okay, it's cool. I wonder how well it runs on the AMD. Okay, something to look into. Okay. So here's an example of how to generate code for libc function using llama.cpp command line interface utilizing wizard coder, etc. So llamaFile, we put this model in. I am not entirely sure what this means. Why do they need to define the mem copy function here? Oh no, okay, they're not. No, this is the completion. I see. Okay. So now, okay, now I want to do two things. One is we know how to run. Actually, let me stop this. We know how to run the LlamaFile server, so we can call the LlamaFile. I want to be able to now either create my own Llamafiles or run whisper and also call it from here. Okay, let's just continue here a little bit. A lot going on. Okay, creating llama files. Lava.llama. If you want to be able to just say and have it run as a web server without having to specify arguments, then you can embed the weights and a special args inside, which specifies the default arguments. Okay. First, let's create a file named args, which has the content. Okay. So that's basically what we've been seeing here in the file. As we can see above, there's one argument per line. And then there will be more, okay. Okay. I should probably know, but I'm not entirely sure what this is. Ah, okay. Uh, okay, let's ask Llama. Okay. Okay. So MM project Virgin files. I'm not sure if I know what they are, but okay. What are files? Okay, binary format that is designed to fast loading and saving of models and is everything. Okay. Global alignment. Okay, so in the successor to these ones and designed to be unambiguous by containing all the information needed to load the model. Okay, it is also designed to be extensible. Okay, specification. So it's a single file deployment. It's extensible. So new features can be added without breaking compatibility. Okay, mmap compatibility. Okay, models can be loaded using map. Oh, sorry. And easy of use, full information. Okay, so we get the model, the version, experts count. It's funny how an implementation detail went into the standard, and then parameters, encoding scheme. Okay. So it's some magic number. I'm not sure what that is yet. Then the version. This is probably just for validation. Oh yeah, yeah, exactly. It's just the format. Then the number of tensors. And the metadata count. So a bunch of, okay, then the metadata. Tokens, etc. Yeah, okay. The model. Then the tensors. And then the rest of the file. And I guess, okay, yeah, well, not entirely sure. So dimensions. Oh yeah, okay. So then the actual data. So these ones just define the metadata of the tensors and the offsets to how to get it, and then they're all packed in here. Okay. And file 10. Okay, cool. Okay, so that's cool. So we got basically it defines what the format is, defines the version, defines the tensor count, which allows us to load this section here. And so far here we are in fixed sizes. And then the metadata key count, so the number of parameters of key value pairs. The only thing I do not understand is, or not yet at least. Okay, so we have fixed memory size up to here. Then the tensor count gives us the size of this. This gives us the mappings to the rest of the file. And the key count gives us the size of this, I would assume. But we have some variable length attributes, so I'm not entirely sure if this is what they mean. I'm not entirely sure how this works. Key value pairs, but like for example, this one, I mean, yeah. metadata value. So the key of the metadata, it is a standard caveats. It must be a valid ASCII string. So far, okay. It must be a hierarchical key where each segment is lower snake case. Okay. Must be at most. So there are some. Oh yeah, no, that okay. Ignore. Any keys that do not follow these rules are invalid. Okay. The key must the type of the value. Okay. And the value. So this is the trick. Okay, so what is looking like is that you actually cannot load all these sections without loading the metadata first because you won't know. Actually, it would be interesting if they package the size as well. Like if I want to just skip ahead and load tensors for some reason and skip all of this. Maybe you never want to do that. Okay. So now the metadata value type could also be this. Okay, could be an array of that as well. Number of elements, etc. Okay. At least I understand how this loads. So as you load, so you know how many values exist. You can start loading them by type, and then you kind of keep going, almost like a linked list. And yeah. Then at the end of that, you have the tensor count. This will match here. I don't think there's any science there. And then this is the block of all the tensor values. Standardized key value pairs. Okay, the following key value pairs are standardized. This list may grow. Okay, where possible, names shared with the original model definitions to make it easier to map between the two. Okay. Describe what architecture this model implements. Oh, I see. So, okay. So my understanding now actually is that given the type, the architecture, the general name, etc., there's kind of already some assumption as to what values go here. Although you still cannot skip and know the size, but that's fine. And what they're saying is that you want to have this be hierarchical in the sense that there's like general llama specific ones, tokenizer specific ones, and then you can add yours by adding your like subtype. Okay, like this. Okay. Okay. Cool. So we should be able to load. Actually, it would be a cool project just to create a simple loader for the file. Not now, but yeah, make sure I understood it. So that could be a mini project, is to use Cosmopolitan to create a GGUF loader. Okay, let's continue. So we now have here we have model, no. So we have this here, and also Mistral. Okay, so let's try and convert this into a llama file. So first, okay, so what they're saying is that we need to make there, and it will be insert. Why is this not? Okay, so copy Mistral. Actually, I'm not going to copy. Ah, so what we're going to do now is, ow, we're going to do this Mistral, and we're going to place it oh, in here. Oh, this happens a lot. And we're going to place it in projects, streams, research. There, okay. Okay, so we got it there. Okay. Uh, let's go back here just a second. Let's ignore the models. Oh. Oh, sorry, I completely missed the comment. I was not looking. Hi, I hope you're well. Is it possible to ask a home networking question if it's possible? I guess, I mean, if it's still there, I actually don't know when this was sent. Please go ahead. I'm not sure if I will be able to answer, but yeah, go ahead. So if you're still there, pressure Jaguar. Hi. uh, what kind of home networking question do you have? By the way, just a heads up, we're looking into running models locally and converting models into llama files, so might be quite far from home networking, but let's see, I can try and help. I should probably have like somewhere where the comments show in the stream so I can also see them. How would you do that? Hmm. Okay. It's kind of frustrating, I must say, when I miss a comment and I'm so bad at this. I have no idea how these things work. So this was about 10 minutes ago. Okay, so I probably missed the person. So, yeah, I need to practice. Okay, so first let's touch a RX file. And we're going to copy this first. Now here we're going to swap this. So it's going to be our Mistral. I am not sure if I have this M project thing, so I'm going to take it out. Host. Do we have port? Maybe. Let's try. Port. We're going to put it on 1, 2, 3, 4. Actually, sorry, 4, 3, 2, 1. Okay. Okay, and then this is how it just says that there are other arguments to load. So it's saved. Okay, optionally specifies where any additional will be passed. Next, we'll add both the weights and the argument file to the executable. I'm not sure if I understand this step. Oh, I see. So this is probably like the standard one with nothing inside, and we're going to put like package more data, the model data into it. Zip align. Okay. We will need to read more about the model structure. So, okay. So CP user local. What is this? Local bin llama file. Do I have it? Hmm. Hmm. Mistral llama file. Hmm. Okay. Which llama file? Ah, maybe I should install it. Uh, okay. So you basically want the raw llama file. Mm. Trying to avoid having to build it. Okay. So let's see if we can get it. Llama file. There you go. I should have checked the releases. Okay. Well, hopefully this is what we need. Okay, so we'll copy that into here. Okay, and now what we do is again another copy for now because I want to keep the previous one into Mistral llama file. Okay. Llama file. This is also ignored. Okay. back into that. I may need to go very soon, so let's see. Let's try this quickly. Zip aligned. Zip aligned. What commands do I get? No, not this. Do I have it? No. Last time I did this, I regretted. So let's see. We may have to end here. Yeah, I'm regretting this. Okay. Oh. I mean, it wasn't that bad. Okay, zip line. No, it was. Okay. I'll have to figure that out. So, okay. I don't want the Android one. Submission a commit message with get revision from the file you used. Okay, that way. Okay. Actually, kind of feels like it should be part of its own metadata, but one way to do that is embedding a notice in your llama file. Ah, okay, using simple line. Mm. Okay, one thing I want to do now is just a structure of Llamafiles. What is inside? Okay, so this is what it is. Ah, okay, cool. So is it on tools? Ah, so I probably need to build it. Or do I? Releases. Hmm. I will have to build. So I don't have time for that today. Cool. Okay, I cannot run that today. I'll leave that for part two. But my understanding is that the llama file already has like everything it needs to run, and then we're basically packaging, we're just pushing like the GGUF as the memory block already that we want to have mapped into memory. And well, this is me making some assumptions, but then the Llama program or executable has a loader for GGUFs. So, and as we saw, we can, okay, let's go back to GGUF file. All right, so we can know that which file we're referring to. So yeah, my understanding is that what we're doing there is just pushing all this into the llama file itself at the end. So kind of feels similar to this as well. And with the arguments at the end. I do want to see the structure of this. And then we still need to have the memory alignment correct, although I'm not entirely sure exactly everything that this does. But okay, I understand it has to do with the pagination in the memory as we write all this to memory, so that it can be easily mapped and pointed to. Anyway, I think, okay, so I think I'm good to stop here for tomorrow or for whenever I do this again. For part two, I think what we're going to do is finish this. So we're going to actually build Llamafiles, the tools, finish converting our Mistral, and then we're going to try and understand the structure of Llamafiles and how the zip align works. Okay, let me just add this, add Mistral args. Okay. Okay, so for today, I think that's it. What have we done? Just kind of semi-randomly explored a few places. We looked into the file structure of GGUFs and what goes into it. We're looking into Llamafiles. We run Llava using a Llamafiles. We did not get to run Whisper. Well, I executed the Llamafiles of Whisper, but that's it. Yeah, and then next, we're going to be looking in more detail into Llamafiles and how that works and how we create our own. Probably Whisper, and then building some C code. I mean, I actually would really, really like to create some C code that loads these files. That's it. Okay, so anyway, so this will be on YouTube. Don't forget to follow on YouTube as well. So it's the same name, and it's also linked in the profile. And yeah, I hope this was useful in any way. The streams coming up will be of similar style, just me randomly looking into these things. My intention is to go much deeper into how some of these things are built and created, and go into running more like local models, maybe look into on-edge devices and models like Raspberry Pi, etc. So yeah, that's it. So thanks for coming. See you soon.